Professor Zhang is the director of Beijing Key Laboratory of Indoor Air Quality. He's also the vice president of the ISIEQ Academy of Fellows, chairman of Association of Indoor Environment and the Health of China. His research interests are indoor air quality and building energy efficiency. He has published over 270 papers in international journals. He is also the co-editor-in-chief of Handbook of Indoor Air Quality and associate editor of Energy and Buildings. Today, he will introduce us to research on fundamental problems of healthy and low-carbon buildings. Welcome, Professor.
Thanks, Chair, and thanks for the organizer of the international seminar to provide me a chance to introduce our recent work, and nice to give a presentation after Michael Davis. I'm Yinping Zhang from Tsinghua University. The title of my presentation is Research on Fundamental Problems for Healthy and Low Carbon Buildings. There are three parts. The first part is background and problems. In creating healthy, energy efficient buildings, we should find and solve the important problems. How to find them, Kurt Smith said, follow the risk, don't follow the money. In indoor air quality control, there are four fundamental problems. According to a paper published in Lancet 2020, it says perimeter depth in China due to PM 2.5 and ozone is over 1.8 million, and takes about 28% of the global value, rank the first in the world, and most exposure are indoors. In fact, there are more indoor air pollutants and more diseases. Therefore, the indoor air quality problem in China is a big problem. There are four fundamental important problems. The first is what pollutants to target. The second is how to control them in design stages. The third, how to control them in operation stage. The fourth, how to evaluate the effect of the control. Previously, engineering science researchers go deeper and deeper. Medical science researchers also go deeper and deeper. However, it's not enough. They should shake hands each other. In this way, they can write the first capital letter of the health. With this cooperation, they can develop healthy building, healthy city, and so on. Second part is research advances. For problem one, what indoor air pollutants to target? China Indoor Air Quality Standard was launched in 2002. Mainly, it based upon the WHO guideline and many standards or guidelines in developed countries. However, there are some problems. Why? Maybe they didn't match Chinese situation. In China, what indoor air pollutants should be targeted? We should understand Chinese situation and Chinese indoor air quality problem. To address that problem, we put forward a method to use disease burden. This concept was put forward by American professor Murray in 1994. They use daily to measure the disease burden. Daily is the abbreviation of disability adjusted life years. For life expectancy, if people get ill, maybe heavy death. So it will last a lot of years. It is called years of life lasted equals number of deaths multiple life expectancy minus age of death. And even the person don't go to death, he get ill, it will lost some ability to work. It is called years lived with disability equals number of incident cases, multiple disease duration, multiple disability weight. We find the candidates of indoor air pollutants from the Chinese standards, air quality guidelines, and the indoor air pollutants with cancer risk data. This is the indoor air pollutants list. And at first, we do some systematic review. We dig out the data from the database, Web of Science, and so on. The period is from January 2000 to the December of 2017. Each paper only reported limited data. With this limited data, by using the Monte Carlo method, we can get the large scale or even the whole country exposure distribution. I will skip the details. And from the literature, we can get the concentration and the response relationship. For example, this is for the PM 2.5 concentration response relationship. And also there are for many other diseases, for example, ischemic heart disease, lung cancer, and so on. After that, we can estimate the burden of indoor air pollutants in China and compare them to Europe and USA results. This is the China results. From these figures, it is seen that for the burden of indoor air pollutants in urban China, PM 2.5, benzene, CO2, NO2, and ozone rank top 5. And this order are different from those for the results of the Europe and the USA studies. And it is also seen that in China, the daily rate PM 2.5 takes about half of the whole value, and the other chemical pollutants takes the remaining half. But this has not been recognized before. And it is also seen that in China, this burden of this almost 5 times of that in Europe and in USA. So in China, indoor air pollution problem is a big problem. Maybe in Europe and in USA is not so important. Problem 2, how to control the indoor air quality in the design stage. There are several stages to control the indoor air quality. Design period, construction period, finish period. In China, in the available engineering system, before, there are only this period. By this standard, national standard, it can determine the engineering is okay or not. If it is not okay, the building cannot be used or go to sale. However, if the indoor air quality is not okay, it's too late. The cost to solve the problem is very higher. If we can solve the problem in the design period, the cost can be very low. Therefore, we want to solve the problem in this design period to give the design evaluation to determine what kind of material should be used, how much it should be used, what kind of air treatment system should be used. And by this way, we can solve the problem much earlier. But in China, previously, they use the concentration of the formaldehyde and VOC use the total concentration, we think it's not right. Why? It is not directly related to the emission rate, and it cannot predict the indoor air quality concentration, indoor air pollutant concentration in real environment. We found that we should use the admissible concentration, but in the common conditions, this ratio, admissible concentration to the total concentration, is only 10% and is not constant. Therefore, we put forward to use the animal concentration to judge the green degree, because only part are admissible. And we found that only the kinetic energy is greater than the bound energy, the molecule can be admissible. By using the kinematic theory, we get this ratio to derive an equation. With that, we can know the influence of the temperature on this ratio. And the results are validated with the experiments. And how to control the indoor air quality in the design stage, we also need the method. Previously, for USA and the European countries, they use steady state method with the ventilated chambers. Put the building material into this ventilated chamber, then record the concentration curve. When the curve reaches approximately the steady state, they can estimate the emission rate. However, this emission rate is restricted to the test condition. And it cannot predict the indoor air pollutant concentration in real environment. Therefore, we develop a transient method with closed chamber and derive the equation to predict the concentrations. By this method, we can measure the emission parameters. Therefore, it can overcome the limitations of the above standard methods. And in USA method and the European country method, the test time are quite long, from 7 days to the 28 days. With our method, the time can be shortened greatly. And also, we developed or invented various sea history chambers, 30 liters to test the building material, 30 cubic meters, and 3 and 30 cubic meters to test the building material of furniture. We also invent standard reference for formaldehyde benzene. It gets Chinese standard material certification. It guarantees the reliability of the test results. Based upon the sea history method, we added 2 standards. One is Chinese national standards. The other is for the building material. And the method has get good evaluation from the Professor John Little, USA Virginia professor. And in the building environment, he write a review paper and a separate session to introduce our sea history method, and think it's quite convenient and time efficient. And the National Institute of Standard and Technology list of USA also use our standard reference. Then we prepare or develop a software to estimate the indoor air quality at the design stage. With the indoor material and furniture emission parameters, input them into the software, we can predict the concentrations for the indoor air pollutants targeted. By using the method, the data, and the software, we also have to prepare the standards. Is Chinese health building standard, evaluation standard, and also the indoor air quality assessment for the public buildings. We also develop software to design to score the indoor air quality. And in China, the health buildings located over 20 provinces, and the building area has been over 30 million square meters. Problem 3, how to find the most economic control strategies. For indoor air quality control, we want to control the indoor air from state A to state B. State A is not certified. State B is expected status. But the problem, how to minimize the cost? The cost can be energy consumption, can be carbon emission, or can be just economic cost. By using the traditional method, it's impossible. Therefore, we develop a new method. It is called inverse problem method. The new approach can be illustrated by this way. For the traditional approach, we know the given process and equipment parameters. We can know the temperature, the concentration of indoor air pollutants. Then we can know, is it certified okay? If it is not okay, we should use HVAC system and air cleaning system. But if we want to get the expected indoor temperature and indoor air quality, what is the best process or devices or control strategy? This problem, we use the functional problem and inverse problem method. Functional is its dependent variable, it itself a function, is not a function. In Chinese, it is called 泛函，和普通的函数不一样。That's why we have to use a functional problem with the inverse problem to solve this problem. I just give example how to use it. In China, especially for residential buildings, there are two popular systems. The one is mechanical ventilation system with filtration. The other is natural ventilation system with an air cleaner. What we want to optimize? We want to optimize the airflow rate for each system. That is, we want to find the airflow rate for each mode. What's the constraints? The constraints are we have to meet the standards for temperature and for the relative humidity, and also the concentration for the target indoor air pollutants. What's the objectives? The objective, we want to minimize the energy consumption. Certainly, we can also minimize the cost, depends the users. We have to use a functional method I just mentioned before on my last page. This cost is a function of the determined function, that is the airflow rate, and with the constraints. After solving the problem, we get the principle. The minimal energy consumption corresponding to minimize this equation. It means for each specific concentration of indoor air pollutant, the ratio of the concentration to the threshold should be less than 1. From this principle, we can know how to operate or how to control the indoor air pollutants and guide the operation of each devices of each system. Just to give an example, we consider a bedroom in Beijing. This bedroom is standard bedroom. The information can be seen from our previous research article. Due to the time limitation, I skip the details. I just introduce the result. After optimization, compared to the traditional control, the energy consumption can be reduced about 12%, and the cost can be reduced or saved 20%. Problem 4, how to evaluate the control's effectiveness. Usually, we only use the concentrations. If it is lower than the thresholds, it's okay. However, it's enough. For the indoor air pollutants, we can know the components and know the concentrations. And by the blood sampling or urine sampling and medical analysis, we can also know the indoor exposure. We can also know if the people are sick or not. But what happens during this process, we don't know. How to solve that? We can use biomarkers. However, for different health risks, we have to use different biomarkers. By using the biomarkers, we can know the biomarker level for the control case or uncontrolled case, or for different control case. From that, we can know how to control the indoor air pollutants. That is say, we use the intervention and biomarker approach. This is commonly used biomarkers for indoor air quality standards. According to the USA NIH report, it is said their use in clinical research and practice has become so commonplace that their presence as primary endpoints is now accepted almost without question. We use that methods to carry out an intervention study in Changsha. Yes, in Changsha, broader company. In the office and the dormitory, they use such system, air cleaning system. The test period is during this period. The objective of this study is to study the health impact of the following system. This system, they use the ESP with filters, and the ESP will produce ozone a little bit. However, its concentration is still much lower than Chinese indoor air quality standards. This is the first study using biomarkers to evaluate the health effects of PM 2.5 and ozone in real indoor environment. This is a fresh air system with a filtration and air cleaning component. This is the first component is bag filter. Second is ESP. It will introduce a little bit ozone. The third part is HEPA. At the inlet, this is the PM 2.5 ozone concentration. And with the fresh air go into this way, the pollutant concentration change this way. Here, ozone will increase a little bit because of ESP. We use 86 subjects, separate them into two groups. Group A, 34 people. Group B, 52 people. And 3 stages. Stage 1, stage 3, just as a common stage, as they used in the office and in the residential building. Only for stage 2, for group A, we don't use these two parts, just use the back filter. For group B, we don't use ESP. There are 4 clinic visits, 2 weeks between. For outdoor pollutants, we use the data from nearby air monitoring site. For indoor air pollutants, we measure by ourselves. For the biomarkers for different medical response, we use different biomarkers. I skip the details. And we do some clinical visits. In fact, this research is a cooperation research between Tsinghua University and Duke University of USA. The PI of Duke University is Professor Yinping Zhang. And this is Tsinghua University participants, Dr. Jinghan Mo, and others. He is a PhD candidate from the Duke University. This is me to have the breath collection. This is the final representative results. It is found that short-term ozone exposure is associated with lung function changes. It's not new finding. This is new finding. This suggests a possible mechanism by which ozone may hurt cardiovascular health. This paper was published JAMA Internal Medicine. The last part is future work. Previously, we understand the relationship between indoor environment and human by traditional epidemiologic methods. The indoor environment information is very limited, and we get the response, human response, mainly based upon the questionnaire and the simple test. Therefore, we cannot understand the relationship deeply and wholly. However, nowadays, a lot of online sensors occurred, and a lot of biomarkers can be used. So the information are enough. And also, there are a lot of wear, watch, and so on. Phase 2, so much data, how to digest them, how to analyze them. We can use machine learning or AI. By using this approach, we can understand the relationship between indoor environment and human much better than traditional methods. And we can control them intelligently. How to control them intelligently? Previously, for HVAC, maybe we mainly focus on the thermal comfort, pay attention to the energy. Nowadays, maybe carbon emission. The key parameter is COP, coefficient of performance. For indoor air quality, we focus on the health. We pay attention to the burden of disease and the cost. We put forward a new concept, COH, coefficient of health benefit. But for the real building environment, we have to pay attention more. We have to do overall control, how to control, how to optimize the control. We put forward a new concept, COE, coefficient of economic benefit. Everything has to be put into the money. We have to optimize the different or various control based upon the economic benefit. Certainly, it needs multidisciplinary cooperation. That's all. Many thanks for NSC and most and all collaborators, and thanks for your attention. Many thanks.
Thank you, Professor Zhang. It's a very insightful presentation. And next we can have some questions from audience. Professor, I have a question for you.
Okay, please.
And you have talked about a lot of indoor air pollutants, such as particles, VOCs, but there is a very special one besides those, the carbon dioxide. In Chinese standard, there is a limit value of carbon dioxide concentration at 1000 ppm. But recently, there is some studies reported that the carbon dioxide more higher than 1000 ppm did not cause any negative impact on human health or productivity or comfort. So could you please share with us what's your opinion on this topic? And do you think that we need to, for example, change our regulations on carbon dioxide concentration, for example, raise it to 2000 ppm or something? Professor.
Thanks for your good questions. CO2 seems to be very simple, but in fact is very complicated. In fact, the study on CO2 concentration in indoor environment has a long history. The famous pioneers in this indoor air quality field, Pettenkofer, Yaglu, studied this problem. Pettenkofer recommendation is 1000 ppm. Later, this concentration was named as Pettenkofer number. Nowadays, the situation is different. In fact, CO2 itself is not a pollutant. However, it is an indicator of the indoor air quality. Nowadays, ambient air quality is much different from the Yaglu's or Pettenkofer's period. So the indicator can tell us a different meaning. How to set the right or better threshold for CO2? In my opinion, it needs further study. For example, Harvard University published a paper on the EHP paper. They study the association between the CO2 concentration and the productivity, for example, for solving questions, ability, and so on. My opinion, this is not good enough. Why? Depends upon what task to study. For 1 + 2 = 3, I don't think CO2 concentration has a big meaning, but for very challenging problem, it has a real meaning. So next step, I suggest to use some advanced brain analysis devices to study the problem further. I still think it needs further study. Certainly, it's my personal opinion. Many thanks.
Thanks, Professor. That's a very good point, and I'm looking forward to your research on that.
Okay.
And there's a question from Professor Wang. Professor Wang, you may unmute yourself.
Thank you. Thank you, Professor Zhang, for this very informative presentation. So I have a question in terms of the trade-off between the energy or environmental cost as well as the health benefits. I think you mentioned about this trade-off in 2 places in your research. One is when you are trying to do this pollutant control, you said we not only care about to control the pollutants concentration within a threshold, but we also care about how much energy we are using to do that. The second place is you are proposing the matrix called the CO edge, basically, which is like the edge stands for the health benefits, while C, the cost. I guess most likely it might be the energy consumption or environmental impact. So so this is kind of like a multi-objective optimization. So when we have multi-objectives, one is energy, another one is health. When you combine these 2 objectives together, usually we have a weight, or how to manage this trade-off. So yeah, basically my question is, what is your approach to handle this trade-off? you are using a specific weight to combine the environmental cost and health benefit, or you have some other more innovative methods? Thank you.
Thanks for your so important question. We don't give the weight to energy or carbon emission or health. We just put everything into the cost, into the money. For example, if you save energy and reduce carbon CO2 emission, we can change that to the money. If you reduce the burden of disease or increase the health, we can also change that to the money, put everything into the money. Then we optimize according to the economic cost. We can get the best situation.
I see.
Yes.
Thank you. Thank you.
Are there any more questions? Okay, so once again, I would like to thank you, Professor Zhang, for your very strong presentation. And next, let's welcome Professor Boyong Lin as the project PI to give his closing remarks on this seminar. Please.
Yes, thank you, Professor Zhang. Yeah, really
thank you.
Impressive presentation, and thank you for your support. Yeah, so many international and domestic participants enjoy your excellent introduction for high building in this field. Yeah, really thank you for you. So today we thank you, Professor Zhang and Professor Mike, to give us a very interesting presentation focusing on the climate change as well as the high building. And now it's the end of our series seminars on this joint lecture held by UCL and Tsinghua. We focus on the low carbon, smart and health building between this almost 2 months. Thank you for your support. Our seminars have been widely concerned by the teachers and students in colleges from the industry. So according to the statistics, the number of the audience, including those in the Zoom meeting, in the live broadcasting platform, are totally over 10,000 participants in these 4 joint lectures. And in fact, totally there were over 4,500 participants continuing to participate in the lecture and discussions with these distinguished professors from UCL and Tsinghua. Yeah, thank you for your support. I would like to express our senior thanks to all of these professors from UCL and from Tsinghua for their impressive presentations. And also I will thank the 4 young professors for their excellent hosting. And also I would like to thank all these participants. There is good news that we will continue to hold the second joint seminars between UCL and Tsinghua on the middle or the end of August. We hope these seminars we continue get your support and participation. And in the seminars, generally they will be 4 professors from UK and from China and from the other international research institute. And also we continue to focus on the topic of low carbon, smart and health. Yeah, we hope your suggestion to us. And thanks again, and welcome all of you to participate in our seminars in the August. Yeah, see you. Okay, thank you all. Thank you very much. So
Thank you. Bye-bye.
Thank
bye-bye.
you.
See you.
Thank you.
Bye-bye.
Thank you.
Cheers.
Thank you all.
Cheers.
Thank you. Bye.
Thank you all. Bye. Bye-bye. Thank you.